Now, every regular feature size will have a size dimension, somewhere at least. Gotta know where it is somehow. And every feature size will have a tolerance affecting that size. So in this case, you see that it's 0.75 plus or minus 0.01. It's got a maximum limit, which is the maximum material condition of 0.76, or the minimum limit, which is the least material condition of 0.74. Now, these limits of size actually do control form variation. Remember, we had that whole rule number 1 at the max material condition. It has to have perfect form. So in one way, it can't vary more than that plus or minus 0.01. Otherwise, it will hit either boundary and fail. So going back to it, remember, rule number 1, perfect form at the max material condition. And we have variation permitted as the feature departs from the max material condition so that perfect form is not violated. Now, at the least material condition, there's no such requirement. Max material condition, these are the bounds it can't go beyond. Least material condition, it can be as curved as it wants as long as it has the right size dimension. Least material condition only controls the size. It doesn't have to control its form. Now, individual features are not connected by rule number 1. So just because I have perfect form, it does not mean that all the angles are going to be correct. So this right here, we know we have an angle right here of 90 plus or minus 0.5, and we have these size requirements, which will, for all those dimensions, constrain them to have perfect form. However, that angle can still be off, and so the relationship between those different dimensions will be off. The only thing that controls the relationship is the allowable tolerance on the angle between the features, not these tolerances right here, not their size tolerance. Remember this, otherwise you're going to have some very strange situations happen to you. So let's look at how that perfect form boundary affects flat surfaces. We've kind of been using it for cylinders, but let's look at it for a flat surface. So in any box-like shape, we're going to have a size dimension that's applied to the distance between two of those flat surfaces. And the maximum possible form variation will be equal to our size tolerance. So it will be plus or minus 0.01, so the max it can go up is 0.01, max it can go down is 0.01, so the form tolerance would be the max minus the min, so it would be 1.01 minus 0.99 equal to 0.02. So if I don't need more form tolerance than this, if this is sufficient, that's fine, then I don't need to actually apply a form tolerance. Okay? I wouldn't even need to apply a form tolerance. Now, in most cases with just a size tolerance, I can't go beyond this line right here. However, there are ways to have an exception to rule number 1. For example, actually, I'll go back to this. If we were to apply a form tolerance and apply it at max material condition, then we would be able to break that perfect form boundary. We're going to see that a little bit later from now. I want to go ahead and throw that at you. This max material condition modifier is absolutely amazing. Now, how does the perfect form boundary affect cylinders? Well, we've seen these before, so it's more or less review. And the perfect form boundary will have a perfect cylindrical shape, and the shaft cannot at any point break through that perfect cylindrical shape. So what we can have variation. It can vary in its straightness or in its circularity, but it can't break these boundaries unless some sort of exception is stated. And so in many ways we could say is for these kinds of shapes, if you were to make a hole that had the perfect diameter of 1.01 and my cylinder can fit through it, well then at least my cylinder is not too big or too curved. Now it might be too thin, like the size tolerance might still be off, but its form tolerance would not have been broken the boundary. Now, there are exceptions to rule number 1. One if I apply tolerance with the free state modifier. 2, if I apply form tolerance for straightness or flatness to a feature of size, I can specify that there is additional tolerance beyond my max-material condition. If I apply the independency symbol, then it says that I don't really want perfect form at my max-material condition. I just want to make sure that the size tolerances are okay. And also, it's just not applicable at all to bars, sheets, tubes, and other stock materials. So let's look at how that independency symbol might be applied to a particular object. So in this case right here, I have applied a straightness tolerance of 0.01, a straightness tolerance of 0.01 to this. And this dimension has been applied with the independency symbol. That independency symbol says there is no perfect form boundary. No matter the max-material condition, I just want to make sure that my tolerances are met, that the flatness is at least 0.01, and that the size is never more than 0.065. So as long as it does that, I'm okay with it. And that's what it's looking for. So this can help you out a lot because this is all about functional design. If my part doesn't need to have perfect form at the max-material condition, why force it to? Why force it to? You only want a part that meets the function of its use. And if it can do that in its current form, then that form should pass. And so this is allowing you to have extra tolerance. Because if we look at this, that form tolerance is actually much larger than the size tolerance right here. Size tolerance is plus or minus 0.003. Plus or minus 0.003. So, the size of this at no point can be greater than 0.059 or more than 0.065, but that's just this size right here. It is allowing it to curve, because without that independency symbol, we'd have a perfect form boundary and it would be unable to curve that much. With the independency symbol, it is only constrained to keep from curving by my form tolerance. So a second thing we should get from this is that if you apply the independency symbol, you need to apply a form tolerance as well, because otherwise there's no constraint on how much it could bend or curve or twist. So, I believe that's everything. It is. So thank you for listening, and I'll see you all next time. Bye-bye.